And hello, everybody. Welcome back to General Psychology here with the first set of notes. And I'm Matthew Westra. I'm the one that put together the content. So let's take a look at some of the things for the set of notes here we have in our Blackboard shell. The introduction, that's the section, what you ought to do, reading, videos, class notes, and then doing a discussion board and a brief assignment. So here's where you can link to the free online textbook, or of course, if you printed that off. Here are the 4 sections or modules for this chapter. Why science and research designs, statistical thinking, and thinking like a psychological scientist. We also have, of course, the videos and TED Talks. These are some of the best and brightest, most amazing. So Barry Schwartz on the paradox of choice. We love freedom. We love to have our freedom. We often don't know the limits of our freedom or even what they might be. But he talks about when we have choices, how do we actually respond? Do we like having more? Does it become overwhelming? So take a look at that. The amazing James Randi. He was a prestidigitator. He rejected the idea, the name of magician, because he said, I don't do magic. Nobody does magic. I do tricks, very convincing tricks. And one of the things that he did a lot of in his career was expose frauds who said that they actually were doing magic or psychic phenomenon or whatnot. So take a look at that. He's very entertaining. Molly Crockett is a great video about science and scientific method and what happens when the mass media and popular press get hold of psychological or neurological or any kind of scientific research, and their job is not necessarily to inform as much as it is to grab attention, to entertain, to sell ad space, basically. And so they might oversimplify. And so she gives a case of that and talks about science in general. Here we have class notes and 2 parts. One is a tutorial on research methods, so enjoy that. Number 2 is one of the 2. And here's the tutorial. You'll also have a discussion board, and the discussion, I give you 3 options here. First is introduce yourself. Online can be very impersonal. That's part of why I'm making the video, is so that there's a human being here. We also can look at things like, tell us who you are, tell us how you like to be called. I go by Matthew. Sometimes people shorten it to Matt. That does not work for me. So with yourself, how would you want your name pronounced? Toot your own horn. What's special about you? Why would somebody want to know you? What are your educational goals? These sorts of things. Second option, having an idea about what psychology is. Use this to talk about your expectations. What do you expect from this class? The third, science explores a lot of topics. What are some topics that you think science should not study or explore? Are there that you think are beyond the reach of science? Some people will talk about mystical experiences. Some talk about personal or interpersonal. I've seen movies lately where they want to capture someone's consciousness and upload it into the cloud, and then the idea you could be, after you die, inserted into some computer machine or even the donor body of a deceased human and continue to live. Is that something we should not look at, or is that something we should look at? Any of these, give it some thought. Even if you don't answer that one, it's good to explore the bounds and boundaries of ethics. We also have over here our first of the brief assignments. Brief assignments are graded more according to accuracy of content. So it's not an opinion piece. You have to demonstrate that you know your stuff. So here we're looking at if you were to conduct some research on some aspect of psychology. What would you want to explore? And which terms would require operational definitions? So be sure to pay attention to that part in the class notes. And then offer some operational definitions. Remember, they have to be objective, so any two observers can look and see and agree on whether something happened or not. So we could say, for example, that a cup is full of coffee. So good. We can all look and see the cup is a cup. The cup has coffee in it. The cup is full rather than half empty. Now, that can all be operationally defined. Coffee is good. There's a value judgment. We can't operationally define. So make sure that you attend to that section in the notes and offer up your example of something that you would like to see studied. So let's get back and go into the notes. We've got several sections of notes here. I want to spend a little time dealing with this issue of proof. I recently saw a YouTube video in which somebody operating from a more authoritarian source of knowledge was saying, see, we know for sure because we have these authorities and they tell us what is true in reality. Science doesn't really work that way. We are very reluctant to say we have proven something. At best, we are likely to say that we've proven something can be rather than something is or always is. And the reason for this is that when we look at truth from authority, somebody or some system or some document declares, and we have trust that that is completely accurate and reliable. In science, we start off with an observation. We notice something and we ask the question about it. That becomes our hypothesis. We want to test, but if science is done properly, the goal is not just to prove it or support your hypothesis, but the goal is also always to be skeptical and see what we can do to find flaws in the hypothesis. So we're constantly trying to poke holes in our own ideas. I have an example from time before. Here, I get my prop. So we have here the phrenology head. So here we can see, and it's kind of small for you to read, but each area of the brain was considered to have different functions. Now, we agree with that today, and we've done that by demonstrating when people are having surgery where they take off part of the skull and the brain is exposed. And if you put an electrode to that part of the brain, you'll have certain experiences or sensations. So we do know that there is localization of function. What they thought was that there were many, many more functions that were not simple behaviors or responses, but things like here we see cautiousness back here. So cautiousness includes prudence, solitude, and timidity. And that's going to be right there, right about here. And they thought that since the brain is inside the skull, an area that was more dominant in terms of our personality or thought patterns, that part of the brain would be bigger. Just like if we work out a muscle more, that muscle gets larger, so that part of the brain would be larger. That would push out against the skull and form a kind of lump on your head. So if you feel around your skull, you'll notice that it's not this smooth and even shape, but that there's little irregularities. So they thought if you measure those irregularities, those little bumps, then you can see what this person's true traits are. So we could test for things like goodness of character or even criminality. Here I have, this is, try to bring that up. This is an original of a phrenology descriptive chart. And you can see there's, let's get to one of the tables. It can be very detailed and very scientific seeming, and they did a lot of work to measure people's heads and to compare and to test with things like looking at people who were prisoners. Okay, I had that open earlier. There we have adaptations. So see lists, and then here's the table. So you can see that they were very careful about identifying the areas, matching it to people that they knew. So they gathered a lot of evidence. But with scientific skepticism, we recognize that evidence has to hold up against all tests. And so that's where we're likely to say, we have evidence that supports the hypothesis, as opposed to we have proven. So we don't prove or disprove, we support or refute a hypothesis. And to say proof, you or I in our everyday conversation are going to say, well, it's been proven, or, they've proven, or this is true. And what we technically mean by that, without necessarily realizing it, is I'm convinced it's good enough for me. But for science, proof would have to involve 100% of all possible data in order to declare that something is proven. Otherwise, it could be a coincidence. I give you the example in the notes of flipping a coin. We flip a coin once, it comes up heads. Okay, we know it can come up heads. But if we flip it 1,000 times in a row and get heads every time, we don't know that on the 1,001st flip it might come up tails, or that we just had a random, bizarre run. If we did an infinite number of coin flips, then we should even expect 1,000 in a row at some point. Maybe with this coin, we started off at that point. So we take generalities and use those as our hypotheses, and then we try to poke holes in it. That's the scientific process. So hopefully that helps clarify it a bit. And I'm going to sign off, and I will see you with a brief video for the notes. Thank you. Bye-bye.